Here's a polynomial, 2x cubed plus 15x squared plus 22x minus 15. You might have a problem that says find or put it in factored form. Or it might say find the zeros and show your work. That's the key to it, because if it just said find the zeros, I'd throw it onto a calculator and see what the zeros are. But it might say show your work, so we'll have to show our work. First, we have to find the possible zeros. And the rational roots theorem says that the possible zeros are going to be p over q, where p is the factors of the constant and q is the factors of the leading coefficient. So what are the factors of 15? And we don't have to worry about sign because everything's going to be plus or minus anyway. So it's 3 and 5 and 15 and 1. And it doesn't, it's minus 15 and minus 1, or in this case, because it's negative 15, it's 1 and negative 15. But it doesn't matter because all of the possible zeros we find are going to be plus or minus. And then we have 2. Well, the factors of 2 are just 2 and 1. So the possible zeros are plus or minus 3 over 2, plus or minus 3 over 1, plus or minus 5 over 1, plus or minus 5 over 2, plus or minus 15 over 2, plus or minus 15 over 1. And then if we graph this, sometimes they'll give you a zero. They'll give you a factor x plus something. Or they'll give you a root plus or minus something. They'll give you one of them. But sometimes you would have to guess which one of these is a root and then do your synthetic division and see which one actually comes out with a zero remainder and is a root and go from there. Or if your teacher allows it, you can use a calculator and graph the function, and we look at the function. I'm doing it on Wolfram Alpha, and you'll see that in this case, okay, it looks like minus 3 is one of the roots. So minus 3. I'll use minus 3, which would make the factor x plus 3. It gives us one of our factors. And then we'll do our synthetic division. 2, 15, 22, minus 15. Bring this 2 down. Negative 3 times 2, negative 6. 15 minus 6, positive 9. Negative 3 times 9, negative 27. Negative 27 plus 22, negative 5. Negative 3 times negative 5, positive 15. And as expected, the remainder is 0. And then we use these numbers to come up with another polynomial, 1 degree less than the original polynomial. So we get 2x squared plus 9x minus 5. And now we have to find 2 more factors. And if we look at our graph again, we see, yes, in fact, there are 2 more roots. Well, we'll find what those 2 more roots are with a very simple method. I'm going to write our 2 factors here, and I have to leave room for a possible number in front of x. And then both numbers that I write here, eventually I'm going to divide by 2, which is the leading coefficient. And I'm leaving room in front of the x for another coefficient. All right, so I take the leading coefficient 2, multiply it by the constant, negative 5, and I come up with negative 10 in this case. Now I want to find the factors of that number, which add up to the coefficient in front of the x, in front of the linear term. Well, in this case, I know that I can use 10 and negative 1, because 10 times negative 1 is negative 10, and 10 minus 1 is 9, so that works. And then I'll just write them here in the numerator of this fraction that I made there with the leading coefficient, minus 1. And then I see if I can simplify anything. Well, in this case I can. I get x plus 5 over 1 and x minus 1/2. So let me rewrite those over here. X plus 5, we're not done yet, x minus 1/2. And now in the simplified form, if I have a denominator remaining in that fraction, I just want to multiply that denominator by x. So I get x plus 5, and I just multiply that, get rid of it where it is, and multiply it by x, 2x minus 1. And those give us our other two factors. And then remember, our original factor was x plus 3 because we saw the root was minus 3. So we've taken this polynomial and put it into factored form. And by the way, the zeros, the other two zeros, come from here. We can just change the sign on whatever the number is. And those are the zeros, minus 5 and positive 1/2 are the zeros. Oh, and I forgot, look at that, that just reminded me. I forgot to write down the other possible zero, which is plus or minus 1/2 and plus or minus 1/1, which is just plus or minus 1. But there it is. These are our factors, or this is the polynomial in factored form. And these are the zeros. Where did I write the zeros? Negative 5, plus 1/2, and minus 3. That was the one we found from the graph. And we have our possible zeros, and so on and so forth. And also showed a pretty simple method of factoring these polynomials. If you have any other questions, ask it in the comment section. See you later.